All right, let's go over this warm-up before our mid-chapter quiz, our mid-unit quiz. So here we have, again, a practice with your box and whisker plot. You're making sure. Now, people, put this in your calculator. You go and you put this into your calculator, okay? And you go and type it in your calculator into list 1. So you go put it into list 1, okay? And then you go and you do you go stat over to calc, one variable statistics. Okay. When you do that, then you scroll down and it'll give you the 5-number summary. Okay. So I think I'll pull that calculator up real quick and show you that because I wanted to show you something else on that as well. All right, so here's our 5-number summary. Then, of course, our Q3 minus Q1, and then I calculated the fences, and we did not actually have any data above the upper fence or below the lower fence. Now, you remember, if you have a fence, then pieces of data above it are a dot, okay? And then remember that your whisker cannot touch the fence. Your whisker would go to the next piece of data inside the fence, okay? All right, let me pull up my calculator just real quick because I wanted to show you something. And so while that's working, we'll keep talking here. All right, so what's an advantage of a dot plot or a histogram over a stem and leaf? Okay, stem and leaf, remember those are the ones where you got to like order it. It takes a lot of time and it's kind of tricky. So dot plots can be done in a much quicker way, same with histograms. Stem and leaf plots, you get bogged down with ordering the data within each stem. All right, now a disadvantage of a dot plot or histogram. So let's kind of talk about this. A very notable and definite issue with a histogram is that with a histogram, you cannot see the individual piece of data values. Those are usually bins, and you have data that falls in those bins, and so you don't know how many 250s there are or how many $5 tips there are or whatever. Now, technically, you actually are, and I posted this on my Facebook forum and our textbook. I thought that this might happen. Our textbook author, it was a good enough question that he answered the question because I even quoted what the actual College Board objective said. I said, I'm just confused. Can you see the individual data values in a dot plot or not? Okay. And so the idea that I got, or what basically came down to is yes, you are supposed to be able to tell what the individual piece of data values are in a dot plot, not the histogram, but yes, in a dot plot. Now, look here. So I had posted this question, this problem here. Look at this dot plot here. You know, are these all just only 30 or are these 30s up to 40s or whatever? So this is considered just a poorly labeled dot plot because we don't know if these are all 30s or if these are just numbers in the 30s. Okay. Over here, again, see, and I post this is better because we do, we know this is age in years, but look here, 15 to 20. So what is this? Is this 16 and this is 18s or what? I don't know. So this isn't great, but the technical definition from the College Board says you can see the individual pieces of data or pieces of data very close to it. And every piece of data is represented by a dot. See here, we've got this 2, and then here's 4. So here's exactly 3s. So what are these going by? This came out of a computer printout. Is this 2.2, 2.4, and then here are 2.5, what? And then 3. But each piece of data, this is representing each piece of data and they're relative to their location in the chart. All right, so dot plots, you are supposed to see individual data pieces, so we're just going to leave it at that. And if you can't tell, it's poorly drawn dot plot. All right, shapes. And you need to make sure that you can have you should have more than one indicator of what this is. This is bimodal and it is somewhat symmetric. Okay, so you need to have both those there. This one's uniform and also somewhat symmetric. So you're going to end up having one of these things A, B, or C, okay, and then D, E, F, or G. So one of these things you're going to end up having A, B, or C, a shape, and then a number of modes or uniform. Okay, and so number 6 is skewed left and unimodal. 7 is skewed right. Because remember, this is like your right foot, your big toe, and then down to your pinky toes. This is your left foot. So you're looking down at your foot. That's how those are shaped. All right, next. Okay, so let's take a look at this. Match the histogram to the pieces of data. All right, so first thing you should do is let's take a look at this where they are centered. So see here, I see the mean and the medians are the same. So they're fairly symmetric. So, and what do you notice about these means and medians? What I notice is that one of them is somewhere else. So one of these is centered at 60 instead of being centered at 53. So I'm going to come down here. That's the first thing I look at. Find the one that is centered at 60 instead of 53. So this looks, like it's in the 50s. Oh, see, no here. This one definitely looks like it's centered in the 60s. Okay, that's false. That is not true. Okay, because I didn't look at the scale very well. Look, if this is the center, then that's halfway in between 43 and 63, so that's 53. Here we go. Here is our one that's close to the 60 mark for the center. Okay, so data set 2 is this one, graph D. All right, now the rest of them all are centered around 53. So what is different between them? So I'm going to mark this one out because I'm done with it. What is different between these? Their standard deviation. So there is a big difference in the spread from 1.8 to 10 to 22. So let's take a look at these and see which ones are more spread out or more closely clustered together. And when I first did this, I was very concerned because I was like, these look really similar. Ew, what's going on? Well, I wanted to point out this to you. Look at these numbers down here on the x-axis. Look here. Those go from 48 to 56, and these go from 32 to 82, and these 23 to 123. So based on that, I can tell that the one that is most spread out is this C, graph C. Least spread out is graph B. So that's how then I paired them up with graph data set 1 goes with B, data set 3 goes with graph A, and data set 4 goes with graph C. All right, number 9. Here we go. Let's see. So these are all now drawn to the same scale. These were pretty tricky to look at, and I did that on purpose so that we could have some good discussion on them. Notice all the scales are the same, okay? But they might be like in a little bit different place. So here, which histogram has the largest standard deviation? Explain. Well, that one was easy to tell. This definitely has the largest standard deviation because it is most spread out. Done. Now, the next question though, which histogram has the smallest standard deviation? Okay, so you've got to look really closely at these. So look at this. I see these numbers here kind of far away. So that's the one that I see that is got most farthest away stuff. So if I was going to guess, I'm going to say that this of the 3 that are left, this one has the biggest standard deviation. So D has the next biggest standard deviation. Now let's compare A and B. All right, so look at A and B. Very, very similar. Now their centers are shifted, so that's interesting. So what's the difference? Well, here's where I see the difference. Here and here. In my mind, this little section here was placed in right there. So from A to B, there's the difference. Okay. Now, which one of those has more in the center? More closely clustered to the center? Well, the one with the highest in the middle and the less farther away. So that's A. A has the highest in the middle and then less in the bar next to it. See, this one had less in the middle and more next to it. So more next to it. So graph A has the smallest because it has the data most closely clustered to the center. All right. Explain what other trait about the other two histograms makes you know that they don't have that smallest. I kind of did that already. So D, of course, has these upper outliers. And then I already talked to you about B not having this right here, some more that were in the bar beside the middle, not the most in the middle. All right. Let's take a look at this. Make sure you know that relationship between shape, mean, and median. So here's your skewed right. So when you write mean, median, and mode, you know that the mean is greater than the median and greater than the mode. Symmetric, so these are about the same. Skewed left points to the left. Go with the shape of it. The inequality mean is less than the median. All right, just the real quick IQR and standard deviation outliers, and then here is your describe the distribution with your socks and be specific. This is about flips of coins and such. I'm just going to leave this one here. Honestly, I did not put one of these on the